Hi guys, this is Naresh from PrumoLET Skill Builders, Hyderabad, Secunderabad. This PCB is Reconnect. The error given by the customer is L6. So the reason of L6 is PFC over current protection. If you see the error code data of Reconnect of this PCB, this is, so why the PFC overcurrent is coming is that PFC, so basically power factor correction circuit works based on two factors. One is the voltage at this point, at these capacitors. So this is one, and another one is the load of the compressor. These two. So max voltage limit should not reach and also should not be less. And the current, for an example, if the voltage set point is 300 volts and when compressor starts at 1 amp, at that time, yes, it creates noise, it creates power factor issue, but you can find a noise filter in this PCB. So this noise filter, when the current is low, this filter is enough to reduce the noise. But when the load increases, so this noise filter is not enough to maintain the power factor. So here the limit for the power factor, one is load and another one is this voltage. When the load increases, anyway the voltage will be dropped. So PFC works based on these two factors. And to run the PFC, this PFC circuit required a reference sinusoidal wave. The reference wave is given from, if you observe the circuit, you can see here, you can see the resistors here. Between this relay and these capacitors, there are, you can see that R72, R69, R71. So these are from AC voltage. The resistors are connected from AC voltage. And here this voltage is given to this operational amplifier. You can see here there is an operational amplifier here. If the PFC is not getting started, or if it is giving low AC voltage error or high AC voltage error, you have to check this circuit. Now the issue is PFC overcurrent. Why the PFC is creating overcurrent? So when you observe the issue here, DC voltage, one is AC voltage and sinusoidal reference, and another one is DC voltage calculation. DC voltage calculation is also, this is a 2-channel operational amplifier. One channel is connected for the AC, another channel connected for the DC. Here if you observe, in this circuit there is a problem. So when we check here in this circuit, we found that this resistor is got failed. You can see in the meter. So here this resistor is got failed. See the value, it's 3.2 mega ohms. It is showing 3.2 mega ohm, 3.2 mega ohm. And here another circuit, the same circuit. Here you can see it is showing 7.5K. It is 7.5K. So this resistor is failed. Due to that, here the reference DC voltage is showing low. Because of this malfunction of this resistor, reference voltage is showing low. I'll show you the resistor. Hope it's clear now. This resistor. This is 7.5K. Now this comparator is for voltages AC and DC both. This resistor is failed. Due to that, voltage, reference voltage is showing wrongly. So when reference voltage is showing wrong, the PFC will oscillate more. That's why the overcurrent error is coming. The current limit is reaching, so that's why the error is coming. So when like this type of error comes, you have to check the outputs of this operational amplifier. Normally people checks at PFC section, but reference points also will have to be checked properly. So now we will replace this resistor and let us see whether the problem solves or not. And if I turn on this PCB, see here, this is, you can see here, it is giving error directly. So this is ground. So that means, as this is 15 volts and here it is in one output, this is another output. So if you see here, it is giving a wrong voltage. This output goes here one, see here, this is one. See here it is showing 13.95 volts. This is ground, and here this resistor, this is the reference point. So this is for the protection. Because of this resistor, this controller is not failed. If it is connected directly, controller might might fail. Yeah. So we try to replace this resistor. We'll replace this resistor and see so how the reference voltage is going to the controller. I'll discharge the capacitor. Now capacitor has been discharged. We have replaced this resistor. Now let us see the voltage. Now we have turned on. You can observe here there is no error. You can see here no light blinking, and if you check the reference point, here it is ground. You can take from anywhere a ground, and I'll show you the meter. See, now we are getting 2.7 volts. So previously we got here 13.5 14 volts. Now we are getting 2.7. So the problem is resolved. We'll do the load test once. If it runs well, so everything will be good. Let us connect indoor PCB, motors, load, compressor, everything. When this PCB comes, guys, this entire PCB is blocked with the dust completely, like one layer. After cleaning this PCB, it is looking like this. After when it resolves the issue, we'll clean more. Phase and blue is neutral, and the black one is communication. Here phase. This is for only load test, guys. When you connect the AC at site, you will have to use proper lugs. Ring type or fork type lugs are recommended for these connections. Now both indoor and outdoor are connected. Let us turn on the PCB. You can see now the set is 24 degrees. Indoor motor is started. You can see guys, we can see the PFC. pulses waveform. This is running based on input sinusoidal wave. So how the PFC is running and how the circuit is working, the types of PFCs, everything I have explained detailed, given detailed class in our training center, and we have videos as well in our YouTube channel. Please go to our YouTube channel. You will find all these videos. Try to share the videos to your friends, and please subscribe to get more knowledge and more solutions for these kind of problems. Thank you guys.